Welcome back to another episode of Building the EMG6. In this episode, we're going to assemble the low drag rudder assembly. The estimated build time for the low drag rudder assembly is from 2 to 4 hours. The rudder assembly components are manufactured using a CNC match drilled system. This ensures a proper fit, easy assembly, and minimizes construction time. In the previous episode of Building the EMG6, we assembled the rudder spar subassembly. We did this by inserting 3 inserts into the spar, positioning them, and riveting the rudder hinge nut plates in place to hold these inserts. The construction procedures assume that you have completed these steps or have purchased the pre-assembled rudder spar. To get started, we need to have an overview of what we're going to be working with. The part numbering sequence in the aircraft uses a version of the ATA code. The first 2 digits in the numbering code system identify the primary segment of the aircraft. In this case, 27 indicates that this is part of the flight control system. The second 2 digits indicate in the part numbering system the primary subassembly. In this case, 41 is the code for the low drag rudder assembly. The remaining digits identify the individual parts within that subassembly. So let's go over each part individually so you can get an idea of the makeup of the individual parts within the subassembly. Dash 10 is the rudder spar. Dash 50 is rib number 1 located at the bottom of the rudder. Dash 51 is the number 1 rib support, which ties the 2 legs of rib number 1 together, forming a box structure. Dash 65 is the trailing edge. Dash 53 is rib number 2 on the left side, and rib number 54 is the number 2 rib on the right side. All of the remaining ribs aft of the spar are made up of both a right and a left side that are riveted together. Dash 55 is rib number 2 support, which forms a box structure for the control horn to attach to the rudder assembly. Dash 20 is the right and left rudder control horn assembly, which will be bolted to the frame after covering. Dash 56 is rib number 3 left. Dash 57 is rib number 3 right. Dash 58, rib number 4 left. Dash 59, rib number 4 right. Dash 60 is rib number 5 left, and dash 61 is rib number 5 right. Dash 76 is the leading edge sheet metal with multiple lightning holes in it. Dash 72 is rib number 6, which is the rib for the leading edge top, and dash 73 is rib number 7, which is the rib for the leading edge bottom. Within the spar subassembly, we have a few more components. There are 3 each of the MS201078-4 nylock nut plate, and then we have 3 AN916-416 1/4-inch washers and AN43B-20A eye bolts, and these are the eye bolts that form the hinges for the rudder assembly. The rudder spar assembly includes the dash 10 rudder spar, and then dash 12 the rudder mid support, dash 13 is the rudder spar lower support, and dash 14 is the rudder spar upper support. And last but not least, we have dash 77, which is the leading edge spar. Now that we have an overview of the rudder assembly, let's talk about a few builder's notes. There will be multiple drawings that you will want to reference, all of which are available in the builder's database under Chapter 27-41. All of the components in the rudder kit have an identification label which identifies the part number, which includes a subassembly for which each part belongs to. In addition, there is a picture of the particular component on each label. Most of these labels are placed in a manner so that they're easy to remove from the component. In many cases, the label will simply come off when the plastic is removed from the sheet metal. You may find it helpful to stick the labels to the workbench as you remove each one, as they also provide a visual picture of each part number that may be helpful in identifying the parts as the labels have been removed. Ribs 2 through 5 consist of two-piece ribs, both left and right. In order to help with the orientation and identification of each rib after the labels have been removed, there is a coding system built into each rib. Each rib has an identifier on the forward side of the rib that identifies the rib number by the number of holes that are drilled into the aluminum. For example, rib number 3 has 3 holes, and rib number 4 has 4 holes, and so on. In addition, the ribs that are located on the right side of the rudder facing forward have all of the identification holes drilled at an angle, whereas the ribs on the left side of the rudder have all of the rib identification holes drilled parallel with the rib. Before we can begin assembly, we need to do one more modification to the rudder spar. Because the radius of the bend on number 6 rib, there's an interference between rib number 6 and the top of the rudder spar. We simply need to provide a small amount of clearance by filing or sanding off the outside edges of the rudder spar. A radius or chamfer of just over 1/8 of an inch will provide plenty of clearance. Once you have removed this material, deburr the end of the spar. Now that this is complete, we are ready to begin the assembly process. We're going to start the process of assembling the rudder, starting with the very top rib, this is rib number 5, and work our way down to the bottom, which is rib number 1. We will start with rib number 5 working the process completely, and then we'll duplicate the process for the remaining 4 ribs. First, we will remove the plastic material from each side of the rib sheet metal piece. You can simply grab the edge with your fingernail, peel it back a little bit, get it started, and then with a nice even pull you can get the plastic off relatively easily. Then we'll need to do the other half of the rib number 6. Once this is complete, the next step is to deburr each one of the pieces in their entirety. There's many different methods for deburring, and you can refer to the deburring video if you need additional help with these procedures. Once we have both the right and left side of the ribs deburred, we can cleco them together to form a single rib as shown here. Now, utilizing our spar with the nut plates oriented towards the aft portion, we can cleco the rib in place using 2 1/8 inch clecos on either side to position the rib correctly. We now have the tip rib, rib number 5, completed and installed. It is now time to join rib number 6 to the rudder spar and rib number 6, completing the upper rib portion of the rudder assembly. Once again, we deburr the edges and the holes of rib number 6 before installation. And then we will use 2 clecos to join rib number 6 to rib number 5 on the top of the rib, and then 2 clecos to attach rib number 6 to the top portion of the rudder spar. Now that we've completed rib number 5, we're simply going to duplicate the entire process for rib number 4. We will identify the proper part number for each rib, remove the plastic, and then deburr both the edges and the rivet holes. Next, we can either assemble the rib completely and then cleco it onto the spar, or we can do as we're doing in this section here, and we're doing one half of the rib at a time, and then once both rib halves are clecoed to the spar, we can rivet the two rib halves together. Next, we'll proceed on to rib number 3 and then on to rib number 2 using the same basic procedures. For rib number 2, we will proceed the same as we have for rib number 5, 4, and number 3. But we have an additional component to add to this rib assembly. Rib number 2 has a support rib that bridges the two legs of the rib together to form a structural box that the rudder control horn assembly will attach to. We will take the number 2 rib support and prep it for installation, and then cleco it in place. Next, we will install the rudder control horn onto the forward spar and the rib number 2. We will be drilling the spar holes with a 3/16 inch drill bit, and then the first 2 holes in rib number 2. In the final assembly, we will be attaching the rudder control horn with 4 AN3 bolts, but for now we'll simply use 3/16 inch clecos to hold it in place. The rudder control horn will be installed permanently after the rudder assembly has been covered with fabric. Rib number 1 is a little bit different than the rest of the ribs, as it is a single piece rib that is already pre-bent into the final shape. The procedures are, however, very similar to the rest of the ribs. Remove the plastic, and then deburr both the edges and the holes in the rib. On rib number 1, there is an alignment tab that is used for the manufacturing process to position the rib correctly in the CNC press brake during the bending process. This tab is intended to be cut off before you can install it onto the spar. Simply take a pair of sheet metal shears and trim the tab on the inboard end. There is an additional tab on the outboard end, however this end does not need to be trimmed. Once you've got the tab off, you should use a file to smooth and deburr the area where you've cut it. Next, we will install the rib number 1 onto the spar using 2 clecos on either side. Rib number 1, just like rib number 2, has an internal support rib that ties the two sides of the rib together. Deburr and cleco this in place as shown in the drawings. Now that we have all of the ribs aft of the main spar installed, we're ready to install the trailing edge. You will want to remove the plastic from the trailing edge, and remember that there's also plastic on the inside, and you might as well go ahead and remove it now so that it's not floating around after the airplane's been built. You'll want to trim the lower section of the trailing edge material so that it matches the profile of number 1 rib. You can mark it and then cut it with a bandsaw, hacksaw, or even just sand or file it to the proper profile. Next, we're going to insert the trailing edge material in between each of the rib mounting sections. Start by measuring to ensure that the trailing edge is the proper distance away from each of the aft sections of each rib to ensure that it's parallel with the rib tabs. Notice that there is a difference from the right side to the left side on the distance of the ribs to the trailing edge. The reason for this is to offset the rivets so that they don't interfere with each other. Now sight down the length of the trailing edge to ensure that it's centered on the rest of the rudder rib structure. Then drill and cleco the trailing edge to the number 1 rib on both sides. Then proceed to rib number 5 and drill and cleco that, ensuring that it is also centered during this process. Next, you could drill 1 rivet hole in each of the remaining rib tabs on either side of the rudder, simultaneously ensuring that the rudder trailing edge has no twist and is properly centered. When we began the installation of the trailing edge, we aligned it with rib number 1. This leaves us a little portion of trailing edge material sticking out past the top of rib number 5. This will need to be marked, cut, and trimmed to fit flush with the profile of the top rib. The last rib that we have to install is rib number 7. This is the leading edge lower rib, and we'll use the same procedures that we did for all the other ribs. Just simply deburr and then go ahead and install it. It should be installed with the flanges facing upward. We now need to prepare the leading edge for installation onto the rest of the rudder assembly. Once again, we will deburr the edges, the lightning holes, and the rivet holes. Next, we will prepare the leading edge spar by deburring it. Once we have the leading edge spar deburred, we will need to cleco it in place. We will need to have a cleco about every 3rd to 4th rivet hole. Now it's finally time that we get to start installing some rivets. We can use a hand pop rivet gun, especially on something as small as this rudder assembly because it has a relatively limited number of rivets. But if you've got a bigger job ahead, it's nicer to have a pneumatic rivet gun to work with. We're going to be installing leading edge spar with 1/8 inch aluminum pop rivets, and these will be part number BSPS4-2. Install all of the pop rivets between the clecos, ensuring that you have good pressure to close up the gap between the two pieces of sheet metal. Once you have filled all the holes between the clecos, remove the remaining clecos and install the rest of the rivets in the remaining holes. Next, we want to trim the manufacturing tabs from both ends of the leading edge skin. Trim off the tabs using a pair of tin snips. Then, using a file, smooth out and deburr the rest of the leading edge. Next, we will want to remove all of the rivets that hold the ribs in place where the leading edge skin will be attached. You can go ahead and remove rib number 7 from the leading edge as well and position it into the lower portion of the leading edge skin and cleco it in place. Once again, place the clecos every 3 to 4 rivet spacing. Now position the leading edge skin in place and secure it to the spar, ensuring that you have at least a couple of rivets in each one of the rib locations. Align and drill any remaining holes in both rib number 6 and rib number 7 and secure them with clecos as well. Next, we can start riveting the leading edge skin to the structure. Once again, we will be using BSPS4-2 aluminum pop rivets in most of the locations where the leading edge skin goes through another single layer of aluminum. The areas that will not receive these rivets are anywhere where the skin, ribs, and spars are joined together. We will use stainless steel rivets in these areas after we've completed the other steps in the construction. Once we've installed all the rivets, remove the remaining clecos, except those at the rib locations, and install the remaining aluminum pop rivets. On occasion, you may run across a location where rivet holes are not aligned perfect, and you may need to simply run a drill through to clean up the hole. Use a number 30 drill bit. Next, we will move on to the trailing edge and install the BSPS4-2 aluminum pop rivets into the rivet hole locations, remaining with one cleco during the installation process. Then remove the remaining clecos and install rivets in those holes. Now that we have installed all of the aluminum pop rivets, it's time to proceed on to the installation of the remaining pop rivets. At each one of the rib locations, the stresses are higher and require stainless steel pop rivets. We will be using CCP 4-2 or 4-4 stainless steel protruding head pop rivets, depending on the thickness of the materials being joined together. Refer to the drawings if you're unsure about which holes require which stainless steel pop rivets. We will begin by joining the rib halves together using CCP 4-2 rivets. In the areas close to the spar, you may need to use a hand rivet pop rivet gun in order to get enough clearance to access the rivet right next to the spar. The rivets located where rib number 5 and 6 are joined together and the rib spar locations will require CCP 4-4 rivets. Remove 1 or 2 rivets at a time, leaving at least 1 cleco in each rib during the installation process to ensure proper alignment. We will proceed on to the remaining ribs and install stainless steel pop rivets in these locations. On the sides of the rib, there are rivet holes used to attach the fabric to the structure. These will not receive rivets except for rib number 1 and number 2 at the forward locations where the rib support rib is located, and there's an extra set of rivet holes. There is consistent spacing for the fabric attachment holes, with an additional rivet hole placed between this spacing. You may want to refer to the drawings for proper placement of each of these rivets. We have now finished the construction of the rudder assembly and are ready to proceed to the covering process. Remember that the control horns will not be installed permanently until after the entire rudder has been covered. The final weight of the entire rudder assembly should weigh less than 5 pounds. If you enjoy watching these videos, please remember to like us on the YouTube channel. And for more information about Adventure Aircraft and the EMG-6 electric motor glider, please visit our website at www.electricmotorglider.com.